TCP/IP, the USB stack, graphics stack, FATFS or file systems is a what you call this is a what you call this ready to run sample code. So you just need to build, compile, and download to the flash and run the code. Okay. All right. So inside the cube, package, the intention of the STM32Cube is to actually have a layer on the bottom part which you can adjust, okay, which you can change. Meaning the purpose of the cube is to allow you to migrate from one family to another, from F0 to F7 in a seamless way. So how do we do that? We configure, or we, let's say, design the cube in such a way that the hardware abstraction layer can be changed to L0, L1, or L4, or any other of the devices, okay? So you just need to change the abstraction layer while maintaining your user code. So if you write your code in RTOS now in F0, you want to change to F2 or F4 because your actual project is very complex, all you need to do is to change the abstraction layer here. All you need to do is change the lower layer, or what we call the hardware abstraction layer, and retain your codes that you have done here. Okay? So that's the, let's say, the advantage of using the cube library. In our older libraries, we call it standard peripheral library. If you want to shift from F1 to F4, it's quite difficult because the libraries are not really compatible to each other. You have to do a little bit or some effort to port your upper layer. Okay? So here, we try to improve our library such that you can quickly migrate up and down. That's the advantage of the cube. So here, you have abstraction layers, APIs for each of the peripherals. You have, it's tested by Code Sonar. You have more than this now, for sure, more than 100 peripheral examples. So this is what I call the sample codes that you can use immediately. Okay. The upper layer here is the library for the middleware, and these are the ones that is available now in the cube. So when you download the zip file from our website, it will include some of these libraries. Okay, so it depends also on the device. Let's say if the device doesn't have a Ethernet, of course the pack is like F0. The device that you're using now doesn't have an Ethernet. So when you download the zip file, it will not contain the TCP/IP. But if you download the F4 or F2 or F7, which comes with Ethernet, then it will come with Ethernet. In fact, the higher devices, higher end devices, will have all of this inside the CubeMX or inside the cube library. Okay? So this is what is available now, and all these middleware packages comes with their own example code. So it's not only libraries that we put in there. We put also sample code. So let's say you don't know about Ethernet. Very good. The cube comes with Ethernet. Fine. Or the cube comes with USB. The cube comes with RTOS. But say, how do I use these libraries? I don't know how to use it. So what you do is you go to the library and you look for the example codes related to each one of these. How do I implement a mutex in the RTOS? How do I implement a mail queue in RTOS? You should be able to find example codes related to that. So you don't have to write from scratch. You don't need to read documents. You can just go to the example and see what is the sequence there and try to understand. Then you supplement by reading the documents. Of course, it's mandatory to read the document, but if you want to quickly run sample codes, it's available for you. Okay? Clear? Then, all you need to do is just to write your own code to customize for your own application. So you use the API or the functions, okay, that is available to control the middleware, and to control the peripherals through the APIs coming from these layers, these two ones. Okay? Right. So when so that is the STM32Cube library. Okay. So in this particular case, in our particular case, we will have a look at the F0 firmware library. I will try to introduce the CubeMX now, the PC tool. Okay. So you install this in your PC, and the main objective of the CubeMX is to allow you, again, as I've explained earlier, allow you to graphically assign the pins, enable the peripherals that you want to enable graphically, okay, and to configure the modes of your peripherals, okay, graphically again. So these are the steps, okay. So I will show this later on. We will do this together, okay. First step is for you to select the kind or the part number that you want to use. Let's say if you want to use the part number, or if you want to use the IC that is included here, then you need to know the part number, and you select the part number from the product selector. Okay. The second step is you configure. So once you have selected the part number, it will show you the footprint or the graphical representation of the IC, whether it's BGA or whether it's QFN, etc. Okay. So in this case, it is an LQFP, I don't know how many pins is this, 32 pins maybe. You have a representation of the pins, and this here allows you to enable the peripherals that you want to use, and it will automatically assign to the corresponding pins. So again, graphically assign your pins. Okay? So the hardware guys would like this a lot. Okay? So once you're done with your pin assignments, you can also set the frequency, initialize the frequency of your system, whether you want to run at high frequencies or not. Okay? So depending on your application, here you can configure the different inputs for your clock inputs and system clock. Okay? Once you're done with that, then you can now individually configure the peripherals, including the middleware. So let's say you have enabled the, in this particular example, I think it's the USB stack, if I'm not mistaken, USB device. So if you have enabled the USB in step 1, in step 2 in the pin wizard, then you should find the middleware here as well. So here you configure each part. This is an example of an ADC configuration. So here you set the mode of the ADC. You want the ADC to do what, continuous conversion or one-time conversion only. You configure the channel that you have enabled, etc. So again, it's a graphical configuration. So this is like initializing your peripheral. Only that you're doing it graphically, instead of writing the codes one by one. 1, 2, 3. And then you don't know what is the function to enable the ADC. You don't know. So here, at least it will help you configure the ADC correctly without with minimum chances that you get it wrong. Okay? So once you're done with the configuration, you can also have a power consumption wizard which allows you to simulate the power consumption of your MCU when you go to run mode, sleep mode, standby mode, etc. in low power mode. So at least it will give you a ballpark of how much power consumption that you will have, average power consumption. But this wizard does not create any source code. It's just a reference. Okay? Last step is to actually generate your code. So here, you have the possibility to what? Choose the toolchain that you want. You want IR, it supports IR. You want Kyle, which is the one that we're going to use today, it supports that. You want GCC or what do you call this? The AC6, which is based on the Eclipse GCC compiler, you can also do that here. So you choose the correct toolchain that you have, then you generate your code, and in the end, you will have a project that is complete. It comes with all the files that you need, so you can see you don't need to add the files yourself. The CubeMX will generate the project for you, including the environment of your IDE. And not only that, it will also generate the initialization code depending on how you have configured your peripherals here. So from graphical user interface, configuring the pins, configuring the peripheral, you click generate the code, it generates the code including the initialization of your peripheral. So you don't have to worry about initialization in this case. Because most of the time, most mistakes is coming from the initialization of the peripheral. Why is my UART not sending in this kind of VPS? Why is my timer not running correctly? Why is my ADC not converting correctly? That's because probably your initialization is wrong. Correct? Why is my CPU not running in the optimum, optimized, or the maximum frequency? Probably you meant you committed a wrong code or put a wrong code for the initialization of the clock. Now, using the graphics interface, at least you are sure that when it generates the code is correct. Okay, the parameters are correct. Okay, you get me? So that's the purpose of the CubeMX. It's not going to toggle the LED, it's just going to configure the pin to drive the LED. But to toggle the LED, that's your job. You get me? Okay? So you still need to add your codes here because it's just the initialization that is generated after the CubeMX. All right. Benefits. So I don't have to go through the benefits here. I suppose that most importantly, it's free. You can get it for free. We update this every now and then. Okay? So especially if we have new devices, we update the CubeMX to support the newer families or newer devices. We also update the library, so the PCs, PC software we update, and the zip file, meaning the Cube libraries, we also update. Okay? Alright, so I think I've done the Cube overview already. So you can go through the slides to see what are the files that are generated. So later on, you'll get to see some of these files when we generate the code. Okay, so I'll skip this part because this is a bit wordy. Now, in the CubeMX, remember that when you configure the pins and when you try to generate the code, the CubeMX is actually going to, how does the CubeMX generate the initialization code? For sure, it will need to use the Cube libraries, right? So, in the CubeMX, you have to import the libraries over because it will just look into the Cube libraries and get the files and use it for you. So, one part of the one important installation that you need to do is to make sure that the CubeMX has installed the what you call this, the firmware package for the device that you're using. So later on, I will show this. Okay. So here you can see that in my example, you have for me I have all of the libraries installed. But for you today, you don't need to install all of them. You just need to make sure that the F0, okay, the F0 is installed. Okay, so I will show you this later on. You will find the zip files in the extracted files in the repository where you can find it in this path here. Okay. All right. Regarding documentation for the CubeMX, if you want to know more, if you want to know how the CubeMX works or some of the let's say features of the CubeMX, because I will not be able to show all of the features for sure today. So I leave it to you to explore a little bit more, and you can use the user manual for the CubeMX. All you need to do is write st.com/stm32cube, then you will see a bunch of documentation related to the CubeMX. One of the example or one of the useful document that you can use is the user manual of the CubeMX. So in fact, the demonstration that I'm going to show you later on, you will find the steps here as well. And this will explain more in fact. Okay? So any other details, consult the user manual. Right? Everything is there. Now, I mentioned about the library, which the CubeMX is also using. This is the content of the library. So when you unzip the library, you will have the drivers, which here you will see the abstraction layer. It comes with all the C files for each of the peripherals like ADC, CAN, comparators, timers, all the serial ports, etc. Okay? So these are the drivers. And you will find also under the project folder here, you'll find subfolders that are related to the hardware or the discovery boards or the nuclear boards that you want to use. But because of course the example codes are related to a particular hardware. So if you are using this, this discovery board, look for this part number here in the subfolders here, and you should find specific examples for that particular hardware. Okay, so for example, this is for the discovery board. If you go inside, you'll find examples, and you see that it's a list of what? All the peripherals. So ADC will have 5, 6 examples. Timers will have more. GPIO maybe just 2 because toggling LEDs and input or interrupts and stuff like that. So it depends on the peripherals. The peripherals, you'll have at least more than 2 examples that you will find. Okay? So you have also application related. So you see this folder here. Under that, you have examples for FreeRTOS, touch sensing, and USB device. So as I mentioned earlier, it's not only that we have examples for the peripherals, we have also examples for application-specific libraries, like FreeRTOS, example codes for that. Touch sensing, example codes for that. USB device, example codes for that. If you are wondering what is the code for a mouse, go to the USB device and you should find there HID mouse. Okay? Right. Questions so far? No questions? If you don't have any questions, then I will ask. Okay, or maybe later. Let me finish the slides first, then we'll do a question and answer. So, in the F0 documentation, okay, you will find a user manual there related to the library of the F0. So if you want to know the description of all the let's say APIs or description or overview of the architecture of the library, you go to this user manual. Okay? All right? All right. So before I start, I have here 2. Okay? Or I have 1, for example. So my question, you don't have any question? Are you sure? No? It's clear? Yes.
But the last check, I don't see the graphics middleware.
Okay, the graphics, the graphics middleware is included to the devices that is able to do graphics. Okay, and the graphics library that we're using is that STM from Sega. Yes, the graphics that was shown over there is from TouchGFX, which is a third-party library. And it's not included in the Cube. Although that package is using Cube libraries, but the TouchGFX middleware graphics stack, or let's say middleware library, is not part of the Cube package, as you can see. So you saw there graphics, right? It's the ESTM graphics. And of course, if you it's not included in all of the STM32 package. Let's say F0, I'm not quite sure if it supports the, maybe no, I don't know, maybe not, the F0 maybe not. F1 maybe yes, F2 yes, F4, F7 for sure. Then it will have this graphics library. So you have to choose, you have to understand, again, as I mentioned earlier, the middleware, okay, the middleware library is also dependent on the capability of the MCU. If the MCU, for example, doesn't have doesn't have the performance to do graphics, then we will not include it in the cube. For example, if you download the cube F0, when you unzip, there's no graphics library there. But if you download F2 or F4, when you download and unzip, you will find the graphics library there. Because the F4 or this higher end devices is capable to do graphics because it has more performance, let's say. While on the F0, maybe not, because it only runs at 48 megahertz.
But the graphic has the graphic config like other middleware such as the graphic configuration for graphics.
Yes, yes. So if it includes the STM library, you have the what's it called? You have in the CubeMX a configuration also for the graphics library. So it will include for sure the assignments for the pins.
But the last I checked, it did not have. I used a manual integrate the Edwin manual, not the graphics configuration.
Yeah, maybe yes. We'll have to look into the user manual in this case. Right? So we can discuss this offline because it's very specific now. Okay? If you later on you can speak to us about the what you have seen in the graphics library or your difficulties to use the graphics. Okay? So yes, graphics is included. It's STM and it's not available on all the STM32. Most likely it is available on the higher end devices only. Okay? Any other questions? None? Okay, so I have a question for you before I proceed to this part here. I mentioned about STM32Cube, right? And I mentioned that it is composed of two parts. What are these two parts? Raise of hands. First one that raises hands and answers correctly will get one of this. In the cube, STM32Cube, I mentioned that there are two parts of the STM32Cube. What are these two parts? Oh, come on. I just mentioned like 1 hour ago these two parts in detail. No? So I will answer my question so I can bring this back home. I will award myself now, huh? No? You don't know? Two parts, CubeMX. One is the, what? Cube. I already mentioned one answer. One is the CubeMX, and the other one is? The other one is? The other one is the Cube library. Remember? Ayo. I just explained these two parts for one hour. Okay? Two parts. Graphical user interface, or the QMX, and the Cube library. Okay? Right? So, I hope you understand. Okay? What the cube is all about. Okay, so no gift for you. Nobody's answering. All right, so I'll proceed to the next one. Maybe I'll raise another questions later on. Let's start with the cube, the STM32 Discovery Board. Here we have a series of evaluation boards available from SD, and some are big, some are small. Okay, but the one that we're using today is this one, which is, we call it a Discovery Kit. It's slightly bigger than the STM32 Nucleo, okay? And it has more components inside versus that of the Nucleo board. I suppose you have seen this before, no? And you've seen it over there as well. So we are going to use this form factor, or we call it discovery kit. The evaluation board is bigger than that. Okay? It contains a lot more components inside. You can do serial ports because it comes with RS-232. You can drive some. There's CAN connectivity. There's USB ports. There's CAN ports. There's SD card ports. So there's what you call this? There's a display. So it's bigger. Okay. So for today, we're going to use this a bit simplified form of the evaluation board. Okay, we call it discovery kit. So these are the different components. This part here is the ST-Link. This is the debugger. Here is your target MCU. So this is the F0 that we want to work with. We want to program. Okay, we want to configure, and we're using the ST-Link to download the flash and also perform debugging of your source code. Okay, so the discovery board, all of our boards now, okay, especially the new ones, comes with a debugger on board. Which means you don't need to buy separately. So in this case, it comes also with the MEMS motion sensor, in this case a gyroscope. There's a touch sensing that you'll find here. Some LEDs that you'll also find here, okay, which you can use as an output to toggle the LED, etc. So it comes with different colors, okay, orange, green, red, and blue. You will have also push button. One is a user push button, and the other one is a reset button. So you find it here. The black one is reset of the MCU. The blue one is connected to a GPIO as an input, okay, push button. Then you have a USB connector. So you have, as you can see, two USB here. One USB which is at the middle here, at the center of the board, is the ST-Link for the debugger. And this other USB is connected to this. Okay? It's the USB port of the F0. Okay? It's a user USB, we call it. Okay? There's also an E2PROM connector here. I think this one here. You can use as a E2PROM daughter board if you want to use the dual E2, you know, for the NFC part. Okay? And there are some connectors that you can use if you want to solder some pins. All of this, the pins of the MCU are all located here. Okay? So you can do breadboarding. You can also wire your external circuitry. Okay? The ST-Link here has other features besides programming the device here. If you remove, okay, once you're done with your evaluation, don't throw the board. Okay? Give it to your kid. Don't throw the board because you can make use of the ST-Link to program your own prototype. Okay? What you need to do is just remove these jumpers here, these two jumpers here. It will isolate this part. So you cut away this part here by removing the jumper, and you use these pins to connect to your own prototype so that you can debug, program and debug your prototype. Reuse what you have. Okay? Don't throw it away. Besides doing some, you know, prototyping proof of concept, you use it to what? To debug or program your actual prototype, right? This is one thing that is important that you need to check later on, is that the ST-Link requires a USB driver. So you later on, you should be able, you can confirm that later on by inserting this one here, allow the drivers to install, and make sure that in the device manager, you will see ST micro ST-Link dongle there. So confirm this later on. Huh? In the afternoon, we're going to give you the boards. Try to connect it and try to see if you have the drivers installed properly. Okay? Because if this is not installed properly, you will not be able to program the MCU later on. Right? Okay. Questions? No questions? Questions? No questions? So far, there's only one who was asking. How about the rest? there's only two answers to that. It means that I was able to explain perfectly if you understood it all, or you don't understood at all. Okay, so before we go for lunch, I have 15 minutes to go through this. Okay, so this will be the CubeMX PC tool. So what I'm going to show you is on my PC. I will try to use the CubeMX to configure the pins, okay, and generate the codes and show you how to use it. What you can do is you can just, you just watch, or you can follow me on this. Okay? So I'll give you enough time to catch up, but I have only 15 minutes, so try to catch up with the procedures I do. All right? So here we go. Hello. Hello. No. Okay. So, what you need to do for the CubeMX. So let me introduce. Once you install the CubeMX, you should see a shortcut. Okay. So double click the shortcut, and you should find something like this. So this is the first, let's say, page that you will see. The one thing that I would like to ensure now with you is this part. Click on the help, okay, and try to see and click on install new libraries. Okay? Okay? I want to make sure, okay, so this one, what you see here are the libraries that you have installed under the CubeMX. Okay? So you have, for me, I have all of them, like F7, F4. You don't need to install all of this. What you need to do is to, or to ensure, is to have the F0, this one here, version 1.5 with a green mark here. Okay? You can click like that. Okay? Check it and click install now. Or, because the internet is so slow, what you need to do is just go for local install, okay, from local. Click on this one here, and you go to the files that we gave you. So you have, under the C, right, you have the F0 workshop, okay? Oops. So these are the files you copied from the thumb drive, right? Yes? Then you go to STM32Cube, okay? This one here. And here, I have already downloaded manually the F0 firmware package. So double click on that, and you should find a zip file. You open it. When you open it, it will import the library into the CubeMX. Okay? Do you have a green mark on this box? Who has a green mark? Green. Only 1, 2, 3. How about the rest? Green already? You have green over there? Yeah. On the F0? Yes? Yes, because you cannot perform the CubeMX if you don't have the green one yet. Okay? Okay. So that's one thing that you need to make sure that it's there. Alright? So you can also find the repository, because you are actually importing it, right? So you can find under the updater settings, you will find it here. See that? Repository folder for the libraries. So if I go to this, path, okay, copy, you should be able to see okay, all the files that you have imported into the CubeMX. Okay, so these are, I have the F0 here. This is the zip file, similar as the one that we have on the thumb drive. Then it is automatically extracted for you. Okay, so make sure that it is there as well. Okay. next thing we need to do is, of course, we start a new project. So this is what it would look like. Okay? When you open up a new project. The first thing you will see is a list of part numbers. You will see all of them, like over 600, 700 part numbers. Okay? So you have to select one, of course. Okay? If you know the part number, then you can just look for the part number. You can do filtering by narrowing down the number of part numbers here. You say F0, you say the one with the USB, and you say 32-bit package, for example, or whatever package. Okay? If you can see the part number from here, you can just click on that or double click on that. Then it will launch the CubeMX pin configuration. Or if you don't know the part number, okay, you don't know the part number, but you know what peripherals you need. Okay? You're not familiar with the part numbers of ST. There's so many, okay, 600, 700 part numbers. I cannot memorize myself. Okay? But I know what I want. I want a USB, for example. Okay, so let me just go back to the very beginning. I know the peripherals I want. I want a couple of ADC, okay, maybe 3, 4 ADC. I want an Ethernet, okay. I want an I2C, one I2C. I want an RTC. I want a USB device. Okay, there's none. OTG, for example. Okay. So in the end, whatever peripherals that you have selected here, that you have checked, this area, okay, will be narrowed down to the specific part numbers that is able to support your requirement. Then you select the specific part number. Okay? That's another way. Now, since we're using, in this particular case, we're using this board, we can also select by using the board selector. So you select here, and you choose the particular type of board that you're using. In this case, it's a what? What kind of board is this? This is a discovery board. So you have to, what? Check discovery board. So it narrows down to a couple of boards now. Then you can also select the specific series, okay, or family. Right? So obviously it's this one. So if you look at the one that we're using, it will be the F072 discovery board. Okay? So I'm going to start here. So I double click, or I click OK here. Okay? Or double click. Alright? So the first thing that you will see is the pin out tab. So here, since we are using a specific discovery board, then you will find that some of the pins here are already pre-assigned because it's specific to a hardware, right? So here you will see this discovery board is using these pins for what? Using these pins for LED, using these pins for SPI, etc., etc. Okay? But if you're going to choose like a specific part number, then what you will usually see is an empty what? Is an empty pins like this. Then you have to start from scratch. Okay? So let's start here. First thing I would like to do is I want to create the project. So I want to configure the project, the CubeMX project first. So I go to project, I go to settings, then the first tab here, project, then I write my project name. So let's say Ho Chi Minh test 1. Test 1. Okay? I select a location, then I choose the tool chain I want to use. So you see in the drop down there's a couple of them. This one here is IR. This two here is Kyle, 2 different versions. The other one is Eclipse, based on Eclipse, to Studio, and the AC6 or the software for STM32, software workbench for STM32, and some other tool chains. So for this particular case, since we're using Kyle version 5, then you choose V5. Do not choose version 4 for this exercise, okay? Because the Kyle installation that you have is using version 5. Okay? So choose version 5. Usually I don't touch the default settings here unless if you want to increase the heaps and stuff. So keep it as it is. Next tab is the code generator. So there are several, 3 categories here. First one is the firmware package. I usually choose the second one. Okay? The second one means is that when I generate my project, it will only copy the files that I need. Let's say my project only involves ABC, UART, I2C, these 3 only. Okay? It means that if I choose this and generate my code, only the files that is related to these peripherals will be copied over to my new project. Meaning the USB files, the SPI files, the touch sensing files, the comparator files, for example, will not be copied over. This will minimize what? This will optimize your hard disk drive. Okay? So I usually choose the second one. Then the other categories here are related to whether you want to back up the previous generated files. Sometimes I click this, sometimes I don't. Okay? It depends, so up to you. Normally, default setting is okay. The next one is the hall setting, which basically I usually check the first one. Okay? This is if, let's say, you are not configuring all the pins. Let's say you're not using all the 32 pins or the 64 pins. So here, you can optimize the power consumption of the MCU by setting the pins as analog mode. One thing that you need to understand in MCU, okay? Do not leave any pins floating. Because upon reset, in our STM32, when you reset the device, these pins are input floating. There's a Smith trigger inside. The Smith trigger is detecting the noise from a floating pin, and the Smith trigger will toggle high-low, 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 high-low. Okay, because of the noise, because your pin is floating. So, in order to disable the Smith trigger, you set or configure unused pins, okay, the ones that you're not using, as analog mode. By setting analog mode, the Smith trigger is turned off. And therefore, no more excess power consumption. But take note, this power consumption is only in microamps. Huh? It's very small. But in low power application, every microamps of saving is very important. So I usually, okay, by practice, I usually check this. Okay? Advanced settings is for advanced users. No. Okay, so for now, we'll not discuss this part. So I only introduce the essential parts. Okay? So once you're done, once you have created or named your project, chosen your toolchain, set some configuration for the project, you click OK. You try to save. Okay? So once you save, you will find your files, okay, under what you mean. Yes, you'll find one single file related to the CubeMX. This one. You can open it again if you want to go back to your configuration. Okay? So most time. So the first thing that you need to do is, of course, configure your pins, right? I want to enable some of the peripherals. So let's say enable, I want ADC, maybe 3 ADC. Okay, so as you can see, as soon as I enable the peripheral, the corresponding pins is automatically set. See that? These 3 here. Okay? I want to add more peripherals because my system is so complex. So maybe I add I2C. Automatically adds the I2C here. I want SPI. Full duplex. Automatically adds the pins for the SPI here. Okay? I want UART, for example. synchronous, automatically configures the pin there. So you can set your peripherals through here, or you can manually go to the pin and select the configuration of the pin. I can just click one pin here like that and configure it for something else. Okay? I can click this pin here and I see several options here for that particular pin. Okay? So let's say if I want to set some pins as GPIO, so I can click and then I'll say this one could be an output, this one is an output GPIO, this one is a normal input GPIO, and this one is a external interrupt input. Okay? So you can manually assign. Let's say this one here, I want it to be I2C. Okay? So I don't need to click the I2C here. See, I2C2 is already clicked because I assigned the pins here. Okay? Okay? Now, let's say you as a firmware guy, okay, I assigned the default settings here. And then your hardware guy came back to you. Hey, you cannot put the I2C pin on this side because it's so difficult in my hardware. I need to reroute it back, etc., etc. Okay? Very hard for routing. What can you do? Okay? For your information, in the STM32, some of these pins is remappable, remappable to other pins. So from this configuration, how can you know where you can remap the I2C? Okay? What you can do is you mouse over like that. Okay? And you see this? Control click to show alternate. So you press control and then you click. Okay. So you will see the blue pins there. These are the alternate functions or alternate pins. So now you can remap. You say, hey, hardware guy, my colleague, my friend, I can only remap the pins to this one here. Okay? So you set. So as you can see, it will transfer. Okay? If you don't want this pin here, okay, you can also find the other pin assignments for the SPI. So it's there. Okay? Right? Right? So in this particular configuration, at least you can optimize the pin assignments for your peripherals. Okay? You don't need to scratch your head. How am I going to plan? How am I going to do the pin assignments and optimize all the pins? Okay? The other feature of the CubeMX is that it can also auto reroute the pins for you. You just click your way here, click, 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 click. It will auto reroute the pins. Okay? Okay? So, how do you do that? Take a look at this part here. You've noticed that as soon as I enabled some of the pins here, you'll see some of the assignments here are in red. It means that it's not usable. Why? Because if you mouse over, it says that it is in conflict with SPI1. Okay? Conflict with SPI1. Okay? You can also see like comparator 1. This one is in conflict with one of the, what do you call this? With the ADC. Timer, channel 1. This pins as output is in conflict with what? With I2C2. Okay? Channel 3, input capture pin is in conflict with USAT1. So, assuming that you want to use both USAT and timer channel 4, for example, how can you do that? What you need to do is you uncheck this part here. See that? Okay? Keep current signals placement. You uncheck this. By unchecking this, you allow the system to remap the pins for you automatically. So as you can see, now all the timer channels are available. When I check channel 4 and I click this one here, it will automatically assign to that. Channel 3 will assign to channel to PA10. Okay. Remember that this was USART1RX. Automatically, the USART1RX is what? Is automatically reassigned here. Okay? Okay? So, after you're done with the configuration here, you can proceed to the next one. So here you will see clock setting. Okay? Then you have the possibility to choose the different clock source. So whether it's SSI, a peak clock or whatever. Okay? Then you can also use this to change the clock, let's say 32 kilohertz or megahertz, using the PLL. And when you click that one here, the PLL multiplier or configuration is automatically calculated for you. Okay? If you say HSI like that, and you change it to 48, for sure HSI is only 8 megahertz. It will tell you that this particular clock source is not possible. So you want to use another source. So you click OK, it will automatically change to the possible source for you. So these are features in the CubeMX that allows you to quickly configure your system clock without having so much problem. Okay? Next one is the configuration of your peripherals. So here is the hard work. This is where you configure all your peripherals. Okay? So let's say you want to enable the conversion mode, the DMA, continuous conversion. So once you're done with the configuration, click OK. The GPIO settings, you can see here the different IOs. Some of them are external interrupt. You can configure the interrupt as, let's say, interrupt mode in falling edge, for example. Okay? Some of them are in output. So you can change several configuration here, open drain or push pull, with pull up or without pull up. You can also write your user names here or pin names. So let's say, let's name this as LED 1, for example. Okay? Click apply. The other one could be also an output, could be LED 2, for example. Okay? Like that. Okay? Click OK. So you will find in the pin out, if you change the pin names, so you see the pin names here as well. You know? LED 2, LED 1. In fact, you can also right click on this and enter user label. Okay. So let's say this one is push button. Okay. So you can do all this sort of stuff graphically. You have to configure one and try to figure out why some of them are having some problems, so you have to fix them. Okay. So assuming that you have configured your peripherals correctly, then you can proceed to generate your code. Okay. So this before that there is a power consumption calculator, and here you can actually come up with the several steps to come up with your power consumption. So here I will not go through every one of them, but at least you will see that by coming up with a profile like this, okay, you can have a corresponding, let's say, power consumption profile. Okay. Example that. So you can have a profile of your current power consumption, then it will give you the average power consumption. Okay? So at least you have a ballpark of how much power consumption you will consume if I do this, if I do that. Okay? Then you implement it in your source code accordingly. Okay? If you are choosing a battery here, let's say if you select a particular battery, I don't know what kind of battery, for whatever. Okay? If you select a particular battery, then it will give you the battery life estimation. Based on the average power consumption, you'll get 13 days without recharging your battery. But again, this is only related to the MCU. If you want to add external, let's say, if you want to add external power consumption, you add it here. Additional power consumption, let's say you have an external circuitry consuming like 5 milliamps. Okay, then you add it into your power consumption. Okay, so this one here is accurate as per data sheet of the MCU. Okay, so once you're done, you save your project, then you start generating your code. So you have here two kinds of generated functions. One is generate report. So I'll click this one here first. It will generate a file related to your configuration here. So you can open up the folders. As you can see, there will be more files inside your folder. So before, it was only this one. Now you have a documentation of your project. So PDF will come with all the settings that you have. So pin assignments, you have your pin assignments table, you have your clock tree configuration, you have the parameter settings for all your peripherals. So this is the documentation of your software already. And your hardware guys would love this because it has all the tables, all the pin assignments, and the graphics. And what's more, the power consumption profile that you have implemented earlier will also show up here. And it will give you what? You know, the power consumption details. Okay? Now, the most important one is to generate the code. So you click generate code. Okay, so we're done with the report. Now we generate the code. So click generate. So it will do some user code generation for the initialization. It will also perform, it will also copy the related files, the library files into the new project. And it will build your project. I mean, it will create your projects. As you can see, earlier, you have only 1, 2, 3 files. Now you have more files. And here you will see drivers that you need. So you see, it's not all of the peripherals because of the options that we have configured earlier. It will also come with source files like main.c, it.c, and so on and so forth. And it will also come with the specific folder for the IDE. So in this case, it's using the CAL MDK. So this one is the project for your CAL. Or you can double click this, or you can just open project. Okay? Then what you see is a complete pre-configured project for you, where it has main.c, it has drivers, it has, if there is middleware, it can also come with middleware, and so on and so forth. You will find then, under the main.c, that you will see here all the functions that is generated by the CubeMX. So anything that comes with CubeMX underscore something something, it's coming from the CubeMX. So you see GPIO, init, ADC, timer, UART, these are all generated by the CubeMX. Okay? System clock is this one. ADC configuration is this one. As you can see that? These parameters here, this one here, is similar to the one that you used here. It's similar to this one. Okay? So at least you can understand later on why is this parameter here. And you go back to the CubeMX, you'll find more description there. So what is the next thing that you need to do? You need to, let's say, toggle the LED, right? You can click compile if you want, just to see if the generated files are already working properly for you. So by default, it should work. So if you click compile here, it will compile the code. Then you should have 0 errors, 0 warnings here. Okay? So that's one thing that you can try out. Okay? Then you can now start your code if you want. You can start coding by saying that, okay, after initialization of the GPIO, I toggle my LED. So I write something like, okay, toggle my LED. So what is the function I use to toggle the LED? So in order to do that, I need to go to my gpio.c file, where I can find all the APIs. So you have here gpio.c, right? Okay. So you search for the function, it contains all the function here related to GPIO. So you can search through here, or you can click on this bottom part here, functions, see that? Functions. Then you go to GPIO, you expand, and you will see all the functions here related to GPIO, the APIs for GPIO. So which function to use to toggle the GPIO pin? Which one from here? Huh? Toggle pin, which is this one. Can I use this to toggle the pin? Can I use right pin to toggle the pin? Yes, I know. Yes, of course. But this one is easier. Okay? So you double click and you have this. Then you can copy and then you paste it over here. Okay? Then you proceed by changing the parameters. So what is the GPIO pin that we configured as LED? We go back to the CubeMX, okay, and look at the pin assignments there. PC8 and PC9. So you say GPIO-C, and you say the pin number. Right? Or you can also use the defines, okay? There is what we call a define. So you see here, you have the pin names, right? LED1, LED2. When you write pin names like this, it will also be defined under MX constants. Okay? So you'll find here GPIO LED1, LED2. So in this case, we write the LED2. So this is LED2, port LED2, and the other one is in LED2. Okay, so now you have LED1 and now you have LED2. Then you can put some delays if you want. Okay. So these are APIs that is available for you. Let's say every 1 second. Okay. So who is going to write all this? You. It's not the job of the CubeMX. The CubeMX doesn't know when you want to toggle the LED. It only knows that you want to configure the peripherals. That's it. So once you have done this, then you can compile and download, right? So, for example, you want to change your peripherals. You want to add more. And you think that, okay, I don't need timer 1. So it means that you want to change your configuration. So what you need to do is, first, you have to save your CAL project, go back to the CubeMX, and change. Do the change. Okay? I want to change, I want to add more SPI. Okay? I want to add more ADC. Okay? I want to add my USB. And it's not possible. Okay? I want to add a USART. Okay? So you add. One thing that I would like to, this one I forgot, make sure that you assign the, what? Make sure that you assign the debug pins. Okay? This is very important, by the way. This should be the first part that you need to do. Make sure that you go to sys and click serial wire. So this is serial wire debug is the one that is used to program for programming and debugging. So make sure that you reserve these pins for serial wire development. Okay? Right? Then you save your project, then you generate again. Okay? So once you have done this, of course, you need to go back and what? Configure all the peripherals that you have added. Okay? And try to fix some things that is in conflict. Okay? So go back and configure. Once you're done, you save your project, then you generate. Right? So once you generate, the CubeMX will again reconfigure all the peripherals according to the new configuration that you have. If you have removed some of the peripherals, then it will remove from the code. If you have added new peripherals, then it will add new codes for that new peripheral. But initialization codes only. What will happen to your user code? It will be what? It will be retained, as you can see. So don't open project because the project is already there. You can just click close and open up here. It will prompt you that it has been modified. You just say reload all. Say yes. It's okay to reload. So as you can see, more peripherals are added. New SPI is added, but your user code is retained. Okay? The toggle LED is still there. Okay? Questions? Yes, sir.
What happens if we delete all the domain code?
Sorry?
What happens if we delete the domain from the code?
Delete which one? This one or this one?
Domain.
The comments? This one here?
You use for similar between the software and the code or not?
It will create problems. It means that you will lose this part. So if you want to put your, if you want to make sure that your user code is retained, you have to make sure that your user code is within this user code begin and user code end. It has to be in between these comments. If it is outside, it will be deleted. Okay? So there are several sections in the main.c and the other files. You will find that it is also in the beginning. Okay? So you have begin here for your function prototypes, for your variables, okay? For your local variables, for your global variables, and for your prototypes as well. So you'll find some subsections here, okay? To write your user code. If you want to add more functions, you go back, you go down below at the bottom, and you'll find another section here so that you can write your functions there. Okay? Later on, we have a hands-on or a demonstration using the CubeMX, and it's already a completed code. And you will see that the user codes are written inside this code begin, code end sections. So make sure, again, that the codes are inside here. Otherwise, it will be lost when you generate it. Don't forget to click and save your Kyle project first. Okay, so that the files will be updated. Then you go back to the CubeMX, do whatever you want to do, come back. Okay? Questions? No questions? Very good. You're hungry, I suppose. I don't want to create questions or prolong. So now we go for lunch, okay, for 5 minutes. No. Lunch for an hour. Lunch for an hour, okay? Lunch for 1 hour downstairs. Oh, it's here. It's here, just outside. Is it? Okay, so I'll give Chow the for the instructions of when.
Sau đây thì mời các bạn nghỉ trưa và ăn trưa. Phòng ăn trưa thì ở ngay cạnh phòng này. Các bạn ra khỏi cửa rẽ bên trái là phòng ăn trưa. Và chúng ta sẽ quay trở lại đây vào lúc 2 giờ. Các bạn có thể vẫn cứ để máy tính